Hi students, how are you? I hope that you are doing fine. Now let us do the exercises. Now there are few numericals in your chapter, and the first one is how to find out the prime factorization of composite numbers. Now whenever we do such questions, we will start with the smallest prime number. So the first case is 140. So the 140, we have to do the prime factorization of 140. So let us start with the 2. So it is 70, again 2, we get 35, again 2, we cannot do it with the 2. So 7 5s are 35. So we get 140 can be written as 2 into 2 into 5 into 7. So 2 to the power 2 into 5 into 7. Whenever you write this, always try to write in the ascending order from the smallest prime number to the biggest prime number. Now let us take the second example of 156. Now in the case of 156, we will do it in the same method. So in the 156 again, we will start with 156. We start with the 2. So it will be 7, 8 is 78, again 2, we get 39. Now this 39 is an odd number, so we will do it with a 3, it is 13. So we got the answer. 156 can be written as 2 into 2 into 3 into 13, that is 2 to the power 2 into 3 into 13. Clear? Okay. Now let us do this next one, 3825. Here we get the answer 3 to the power 2, 5 square and 17. So in all these cases, what you have to do is you start with the smallest prime number and keep on dividing that composite number with the prime numbers. So you will get the answer. Next is 5005. 5005 can be factorized as 5 into 7 into 11 into 13. Now next is 7429. So in this case we get 17, 19 and 23. Now let us do another question, question number 2, that is how to find out the SCF and the LCM. So SCF and the LCM, and we have to prove that SCF into LCM is the product of numbers. Please remember one thing, this whenever we do this SCF, the product of the SCF and the LCM, we will get the product of numbers. We get the product of numbers. So in the exam, if they are asking you to find out SCF provided the LCM is given, what you have to do is multiply those two numbers divided by the SCF or LCF, you will get the answer. Now in this first case, we need 26 and 91. We have to find out the LCM and the SCF of 26 and 91. So 26, again let us do the prime factorization. It is an even number, so it is 13. So 13 is a prime number, so we can't go ahead. So 26 can be written as 2 into 13. Now let us take 91. So in the case of 91, let us do it. 91, we can't go with the 2, neither 3 nor 5. Let us start with the 7. So 7 into 13. So 91 can be written as 7 into 13. Now the SCF, that means the SCF which is common there. 13 is common in both the cases. So the SCF will be 13. Now the LCM will be 2 into 7 into 13. So that is equal to 182. This is how we find out. Now you have to prove SCF into LCM is product of the number. You find out that is SCF is 13. If you multiply 13 into 182, you got the same answer as 26 into 91. This is how we prove it. Now let us take next example, 510 and 92. 510 and 92. Now 510, it is an even number. So let us start with the 2. So it will be 2, 5, 5. So 255. Now it is an odd number. We have to do it with a 3. So you know how to the divisibility rule of 3? How to check it? You just add these numbers, that is 2 plus 5 plus 5, that is 12. If it is divisible by 3, in this case we get it 4. That means that number is divisible by 3. This you have already studied in your previous classes. You can check any number whether it is divisible by 3 or not. The simplest way is add all these numbers, all those digits, and if it is divisible by 3, then that number itself is divisible by 3. Now this is divisible by 3, so it is number is 5. So we have to divide it by 5. 5, it is 17. So we can write that 510 is equal to 2 into 3 into 5 into 17. And the second number is 92. 92. So we get this is 46. Again 2, we get 23. So 23 is a prime number. So we can't go ahead of this. So 92 can be written as 2 into 2 into 23. 2 into 2 into 23. Now how to find out the SCF? SCF, in the case of SCF, we know the common, which one is the smallest common thing, that is 2. So SCF will be 2. The LCM will be the greatest power. Greatest power 2 is 2 to the power, only 2 to the power 2. And 3, there is only 1 3, and 5 and 17 and 23. So this is how this is equal to 23,460. So this is how we find out the SCF and the LCM. Now you can multiply the SCF and the LCF, then you will come to know that this will be the product of 510 into 92. Now let us take 336 and 54. So 336 can be written, 36 can be factorized as 2 into 2 into 2 into 2 into 3 into 7, and 54 can be written as 2 into 3 into 3 into 3. From here you can easily find out the SCF. The SCF 2, there is only 1 2 in 54, so that we will take it, and 3, there is only 1 3 in 336, that we take it, so the SCF is 6, and the LCM is, we take the remaining thing, so we get the LCF. Now let us take 3 numbers. Now 12, 15 and 21. Find the LCF and the SCF of these 3 numbers. Now in the case of these 3 numbers, similar method we have done it. So 12 can be written as 2 into 2 into 3. Next is 15 can be written as 3 into 5, and 21 can be written as 3 into 7. Now you see, what is the SCF? So SCF we know that which is common, which is the smallest power. So it is only 3 is common. There is no 2 here, there is no 2 here, and there is no 5 here. So only 3 is common in all 3 cases. So the SCF is 3. And the LCM, let us take the 2 to the power 2 is there, and 3, there is only 1 3 and 5 and 7. So this is how we find out the SCF and the LCM. Now let us take next 17, 23 and 29. 17, this is a tricky question because 17, 23 and 29. these three numbers are prime numbers by itself. So which will be the highest common factor? Only 1, because 17 can be written as 17 into 1, 23 is 23 into 1, 29 into 1, which is common? Common is only 1. So the SCF will be 1 and the LCM will be the product of all these numbers. Understood? So, okay. Now, this is how we do the LCM and the SCF. Now, let us take the next question, that is question number 4. In question number 4, what is given to us is the SCF is given. SCF of two numbers is given to us. That is SCF of 306 and 657 is 9. We have to find out the LCM. Now, we know that SCF into LCM is the product of numbers. Now, we have to find out the LCM. So, LCM is equal to product of numbers divided by the SCF. So, which are the numbers? 306 into 657 divided by the SCF by 9. So, the answer will be 22,338. Now, next question, question number 5. Question number 5 is saying that, first of all, you have to understand the question. It says that 6 to the power n, and n can be any natural number. So, which are those natural numbers? Natural numbers starts with 1, 2, 3, 4, 5, etc. Now, the question says whether 6 to the power n can end with the digit 0 for any natural number n. That means, so let us take, if n is equal to 1, so it will be 6 to the power 1, it is 6 to the power 1 is 6. Now, if n is equal to 2, 6 to the power 2, that is 6 into 6, that is 36. If n is equal to 3, 6 to the power 3, that is 6 into 6 into 6. Now, the question is, this last digit can end with 0 or not? This is what we have to prove. So, if any number, if it ends with 0, then it can be easily divisible by 5. Any number you take it, any number, if it ends with 0, the last number is 0, it will be divisible by 5. Now, we have to prove that 6 to the power n, if this last digit is 0 or not, we have to check it. Now, how can we check it? Now, let us see 6. 6 can be written as 2 into 3. So, 6 to the power n can be written as 2 into 3 to the power n. Here, 5 is not there. Remember, if it ends with 0, then it should be divisible by 5. So, here in this factorization, it doesn't contain 5. So, 6 to the power n cannot end with 0. Now, let us see question number 6. In question number 6, you have to check it whether these numbers are composite numbers or not. Now, we know the definition of prime number and the composite numbers. So, in the case of prime numbers, we have only two factors, 1 and the number itself. For an example, let us take it 7. So, it can only be divided by 1 and 7. Now, what is composite numbers? Composite numbers have more than 2 factors. It will have more than 2 factors. Now, let us take an example of 10. Now, 10 can be written as, it will be having 1 as a factor, 2 as a factor and 5 as a factor. So, these composite numbers have more than 2 factors and prime numbers will have only 2 factors. Now, let us come to the question. In the question, it says that whether that number, you see the numbers, whether they are composite numbers or not. That is 7 into 11 into 13 plus 13, whether this number is a composite number or not. Now, which is common? 13 is common. So, 13 we can take it out. 7 into 11 into 11 plus 1. So, this number, this complete number have another factor other than 1 and the number itself. Hence, this number, because it is a product of two numbers, hence this number is a composite number. Now, let us take the second one. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now, in this question again, 5 is common. 5 is common. So, we can take out 5. What is left? 7 into 6 into 4 into 3 into 2 plus 1. That means it is a multiplication of two numbers other than the number and 1. So, we got a factor which is the number and 1 itself. So, it has got more than two factors. So, it will be a composite number. Since we know the definition of a composite number, it has got more than two factors. So, these are composite numbers. Now, question number 7. This question number 7 is one of the most important questions as far as this chapter is concerned, and this type of questions will be there in your future classes too. Now, let us understand the question. There is a circular path around a sports field. Now, there is a circular, let us take this as the sports field. Now, they are saying that there is a circular path. So, there is a circular path. There is a circular path around the sports field. So, this inner one is your football ground. This is your football ground and there is a circular path around that. Now, there are two players. One is Sonia. Now, let this be the starting point. Sonia. Sonia takes 18 minutes to drive around the field. So, she takes 18 minutes. Now, Ravi takes 12 minutes to complete the same distance in the same direction. So, Ravi is also starting. Ravi takes 12 minutes. Who is faster? Ravi will be faster because he is completing this complete ground in 12 minutes, whereas Sonia takes more time. She takes 18 minutes. So, Ravi is faster. Now, the question is, after how many minutes will they meet again at the same starting point? They are started in the same direction, and after how many minutes will they meet at the same starting point? Now, let us take the LCM. So, in such cases, we have to take the LCM. We have to take the LCM of 12 and 18. So, 12 can be written as 2 into 3 and 18 can be written as 2 into 3 into 3. LCM we know the highest power 2 to the power 2 into 3 to the power 2, that is 4 into 9, that means 36. So, after 36 minutes, they will meet at the starting point. Now, let us have a cross check whether our answer is correct or not. Now, 36 minutes. So, in 36 minutes, Sonia will cover 2 rounds because 2 into 18 is 36 and Ravi will cover 3 rounds because 12 threes are 36. So, Ravi will complete 3 rounds and Sonia will complete 18 rounds. In such questions, we have to take the LCM. So, that is all for today. Let us have a quick revision what we have learned today. So, today we have studied the fundamental theorem of arithmetic. In that, we said all composite numbers can be factorized, can be expressed as the product of prime numbers. There are two conditions are there. It is unique in its own way, and the order, apart from the order in which this prime number occur. Then we studied how to find out the SCF and the LCM of composite numbers by prime factorization method. Just like division method, instead of the same procedure, but we are dividing it with the prime numbers. We will start with the 2, then 3, then 5 and 7, etc. Then we studied this LCM case. This is one of the most important case. Here again we have taken the LCM. So tomorrow we will study the irrational numbers. Thank you.